Okay guys, so in this video we are going to have the ultimate showdown, functional programming versus object-oriented programming. So let's get into it. So we're going to go through a bit of functional programming style and the object-oriented programming style, and then we're going to reason a little bit about the pros and the cons between the two. Now I feel like I need to state that this application that I've built, which is basically one version of the same application in a functional style and one in a more object-oriented style, is a very basic example of how to build an application. There are so many nuances to these different paradigms that won't actually become all that clear until you actually apply these patterns or these styles of working at a much larger project. But I'm going to do my best to make it clearer, at least, as to what's actually going on here. So let's close these tabs down a little bit here. And let's just dive right in. So the basic application is just a REST API where I'm hooking up to a MongoDB instance. And I have two different applications that are listening on port 3000 and 3001. And here is the functional application. And basically all it is a very small REST API to manage a simple data type that we call a user. And that is pretty much the whole application right there. So if we start having a look here and just kind of walk through what's actually going on. The first principle of functional programming, if we're going to just align on some of the core principles that make up the base, is that we want something that we call functional purity. In other words, we want all of the functions that we are using to be pure. In other words, we don't want them to do some type of weird side effect, which basically means that you may have seen this before, that as an example, the database connection to MongoDB. If you have an internal model, as we have in MongoDB, and you reference that model from inside of a function directly, then that basically means that that function there is actually reaching outside of its own context. It's actually connecting to an entity such as the database, and this is outside of our control, and that's what we don't want. We want to be in full control so that that function never actually does any mutation that is outside of our own running process. And that's one of the principles that is very important. And the other principle that is, I'm not saying necessarily a strict thing, but it is something that I believe to be extremely important and one of the cornerstones in functional programming. And that is reusability. So what we want is to create small pure functions that do some sort of work and do that thing extremely well, single responsibility principle, and then we want to reuse as much as possible of that logic, because when we invest in making a function, we treat that as a first-class citizen that does something extremely well, and then we can reuse that exact logic in a higher level function, and then we can actually compose all of our functions together as small, tiny, think of them as Lego bricks or Lego blocks that you connect together to create more and more sophisticated software. And that is pretty much what's happening here. So there has to be an entry point somewhere, and this is our entry point. So you can't do without, like, completely without any type of mutation, because technically this part here is fine that there is a little bit of impurity going on, like as an example that we have these magic functions that we're going to look at, that they basically are our request handlers. So if we look at a request handler here, what is a request handler? So this function here, if we go inside of this function, this is where this code is. So as we know, this is just an express application. So every express application has the concept of a request and a response. And you may know that when you work with Express, the way that you actually return a response or handle a request is by doing something like this. You have some type of response, and then you set a status, or you don't have to set a status necessarily, and then you call .json or .end or something like that, and then you return a payload. Now this is a REST API, so we exclusively work with JSON, but let's examine this function a little bit. So what I'm using Ramda for my functional, these functional helpers. I could write all of these functions from scratch myself, but I don't want to, because Ramda, although I wouldn't recommend necessarily using Ramda in production, because it's a kind of, well, I'm not going to say too much, but it's still in beta, and they haven't been maintaining it all as well as I would like. Lodash has a functional library that you can use as well, but it's also not perfect, so there might be a nicer one. But if somebody bends my arm, I would say that Lodash is probably the way to go. But since I'm more accustomed to using Ramda, that's what we're going to use in this example. So the first thing we're doing here is that we are currying our request handler. Now, currying, all that means is basically that I'm creating I have a function where I pass in a set of arguments, or rather another function that has a set of arguments. And what it basically does is that it allows me to exhaustively apply each of these arguments. So what that in plain English means is basically that if you see my function here, it takes a status, which is a number, and then it takes some function that takes a request and returns a promise or an any, like a promise of an any or just an any. Then it takes the request, the response, and a next function. Notice that this part here is pretty much the same interface as every single request handler has in a standard Express application. Request, response, and next if something goes wrong or like you want to pass down to the next thing, right? These two things are not. These are my own custom things. And if we look at let's have a look here. If you look at how this is being applied, so this thing here is pretty much like saying request, response, next, and then arrow. That's pretty much what it is. Apart from these two extra arguments, and that's where the currying comes in. So a currying function is just a way for me to create a higher order function structure where if I give this return response function that is being created through the currying, if I just give it the status, it's going to return another function that expects a function, a request, a response, and a next function. If I give it both the status and then the function, it's going to return a function that expects request, response, and next. This way I can basically create a dependency injection system that allows me to, well, pretty much, I can just declare an interface and then create new functions from that interface. So what I'm doing here is that I'm stating that, okay, I have this generic function called return JSON response. And what I want is to create another function that knows that it's going to return a 200 response. That's all I want to create. So I give it a 200, a 201, and like all of these different status codes. And then I'm going to get back a function that expects a function that takes a request and returns a promise or an any of some sort, and all of these things down here. And then inside of my function, I basically return, or I have a try catch block around here. So I do response status JSON await, and then I call the function that I have actually passed in. And that's very, very powerful because when I actually then create this thing here, remember the currying. So what I'm doing now is that I have a function, a curried function that expects all of this, but I'm just giving it the function. In other words, I'm exhaustively applying new parameters. So I'm giving it this function, and that's going to return a new function that just expects this interface. And that's exactly what I want, because I just want a function that knows that, oh yeah, in this case I'm not actually taking the request, but here I do. So this function takes in the incoming request and it returns a value, which in turns basically just knows, which in turns returns another function that knows that has this interface. So after basically calling this is equal to getting back this. Next. That exact function. This is the same signature, just calling that function. I hope that makes sense. Currying can be a very confusing topic to quite a lot of people, but once you get it, it's actually fairly straightforward. And you kind of have to get it in order for for really useful things to be possible to do in functional programming. I would say that, at least from my perspective, the three main, really main concepts in functional programming to make this a very productive workflow is to understand currying, composition, And, well, you don't necessarily have to work with monads and functors, but I would say that they are very useful as well. I mean, most people don't actually know that a promise is an actual monad, and we will see examples of that later, but these things are important to know, because if you look at this, if you look at that function signature there, can you tell me what's going on? Most people would say no. And this is one of the cons, I would say, with functional programming, that it's very, you have to understand the theory. If you understand the theory, all of this becomes it almost becomes crystal clear. The code is, on the other hand, extremely dense. It's really efficient and really, really useful to work in this fashion if you can do it well, but it can, for a beginner or someone who doesn't really understand what the right level of abstraction is, become extremely complicated. So the reason why I wanted to create this function is basically because I want to have just a standard way, like a function handler, that it just knows that, okay, if I call this function, it's always going to return a JSON response with this payload that I provide this function, and it's always going to know how to handle an error. So as we can see here, if I call a delete with, let's see here, 3000 users x delete, it's going to return a message, oh my god, you can't delete all the users. And notice that I don't actually have to deal with this in any fashion. In a normal application, like if you're just working in your Express as per usual, throwing an error like this and not having like a try catch or having a dot catch on your promise or something like that will actually return or result in an error. But if we look at what this function is doing, it's actually handling that internally. So this wrapper is just magically, or just without me having to do much, taking care of the error case and passing all of this down until it hits these blocks down here. So if I hit a 404, like that, it's going to return message 404. It's going to hit this line, otherwise it's going to hit this line. So I never have to repeat myself when it comes to this specific part of the logic. I'm actually only allowing the part that is specific, the actual business logic of handling this request, to be the thing that I'm injecting into my higher order function, and then it actually knows all the other stuff around responding and handling an error accordingly. Right, let's have a look at these more specific functions like get all users and create users and stuff like that, because now we're basically done with this part here. So I hope this makes sense. Higher order functions, currying, important things to understand. Users, let's look at users. So here I have a entry point into my file where I basically instantiate, or I create all of my different handler functions, these functions like get all users, get users, delete users, and update users. And you will notice here that I'm doing some magic with like user.find, and then I bind that, and I have all these references where, okay, here for delete user, I'm referencing get user, and then I'm referencing delete one, and then I bind that. Like, what's going on here? So what I'm basically doing here is delivering on that promise that I was stating earlier. As a functional, when I'm writing in the functional style, I want all of my business logic to be contained within pure functions, and a database access such as this thing here, because the user, this is what the user is. This is just a Mongo schema, and we know that any schema access, like doing a find or a save or something like that, that is an impurity. That is something that is that reaches outside of our own code, and I don't want that, because that's something that can go wrong. It's something that makes it very hard to test. And one of the best parts about functional programming is that it's so gosh darn easy to test when you do it right. It's like harmony to test. Doing unit testing is like nothing when you do it well. I'm not stating necessarily that this is well, but it's just my personal opinion. So what I'm doing here is that I'm just constructing these functions that know how to deal with these specific impure tasks, because I need to save something to the database, but I don't want to just include direct access to the database inside of my logic. So finally, let's have a look at our query file here, which is basically just where I store all of this logic that we have. So Here are some helpers. There's things that I'm using in order to do some basic business logic. And here are the exported methods or the exported functions. So let's just walk through this. So first and foremost, we have a function called getAllUsers that, as you can see here, it's gonna, let's just do users like so. It returns an empty array because there are no users in the database here. So it's just going to have a function called find, and I am just giving it a type alias like this, where it says find func or find fn, and it's going to do a type of user.find. So it's really only the same thing as saying user.find, that method. I want that signature on this function, but I don't want to pass in the user because I just want the function. And that's one of the that's something that is different from functional programming versus object-oriented programming. In object-oriented programming, usually what you would do is that you would pass in the entire user model into this function if you were injecting something. But we don't want that. We want the lowest amount of information to actually do the job that we want. We don't care about the user model. We just care about that function that knows how to actually provide that functionality that we're looking for, right? So all getAllUsers, all it really is doing is that it is calling find with an empty query. So that's going to bring us every single user in that entire collection. And that's all it does. So we can see here that the signature is absolutely horrible, but it's a fairly simple thing. All it does is that it's going to return another function. As you can see here, it's a higher order function, so you give it a find, it returns another function that takes nothing and then just calls find. That's it. GetUser is a little bit different. It's using currying here, as you can see, and it's the same process. So we have an async function here that takes a find1, and find1 is equal to the user's find1, which is, as you probably know, find is going to get me a collection of documents, and find1 is going to return a single document if it finds it. And then it takes a user ID, and this is a curried function now. So as we can see, if we click here, no, not that one, not that one either, it's going to be this one, yes. So getUser, as you can see here, it's the same thing. It's just curried function. It takes just the find1 argument, and that's pretty much it. So this now returns this function here. It's just a curried function that expects a user ID, and that's going to return a promise of a user. That's it. And yeah, it's the same principle. So then we have updateUser, which also is a curried function. This is a bit of a special one because in this scenario, making an update is a very similar operation to doing an access. You can notice that these two things here are sort of similar. They're not exactly the same thing. So that's why I'm duplicating myself a little bit here. So I have this thing here, and I call this function here, which returns a collection of things. And here I have a similar sort of thing. I take a function and a user ID, and then I return one thing here. But an update, I don't really have to duplicate the find1 logic, because if you think about it, updating something, well, then I need to find the thing that I'm looking for, like a user, and then I have to apply updates. And I can do that in a more efficient way than just copy-pasting this section here and adding it here. I can use composition. And you can think of composition as a pipeline of events. So what I'm doing here is that I am giving the compose function. Just look at that signature. This is why you kind of need to know I argue that you have to understand the underlying theory to really make sense out of this, because this, I can imagine, is really dense to digest as someone who's not, I'm not going to say enlightened, but still. So all this is saying is basically that it takes a sequence of functions. That's what compose does. And in its base form, all it does is that it takes the rightmost function, takes the input argument, which is in this case this function here, because this compose function, it returns another function that expects an input argument, which is the input that is expected of the first function. So as you can see here, you know that getUser is only expecting the user ID, which means that this entire thing returns a function, and then I give it the user ID. So now this thing is going to be passed into getUsers, this function, and then that function is going to run. And thanks to the signature, we know that getUser returns a user, or a promise of a user. Then I call r.then, and .then is just a way for you to pipe a promise into a new function. So I lift out the promise or the user out of the promise that is coming from get user and just getting the user. And then I have this function here called apply updates. And apply updates is a curried function, and it takes a request, which is this I update user request, and it's just a object that contains the new name that we want to update on our user. And then it takes a user. And since it's a curried function, I know that if I give it just the request, I'm going to get back a function that expects a user. If I give both, it's going to just call the function. And then when I have both of my arguments as an input, it's going to just set the username to the request name and then return the user. And that's why this works. So I've created I'm basically just pre-programming this function to know that, okay, taking the request, and then when get user is done, when it's called, that's going to give you a user. So it's going to pass in the user, apply the update, and then it's going to return a promise of a user. And the same thing happens here. We lift out the user, and then we save the user. And save user is also pretty straightforward. It just takes a user and returns a user. It basically just calls .save here. This is a little bit impure because, well, it's not impure because technically my code, from the perspective of my function doesn't know that save goes to a database. But since Mongoose is designed in this way and the save function is on the model, I kind of have to do it this way. Otherwise I would have passed in a save function that had that logic. But this is a pragmatic approach to solving that problem. Finally, we have a delete function. Same thing here. We curry, and then we give it a function that is expecting a get user function and a delete one function. And these things here, it's the same thing here. You've seen it before. It's just the same signature. It's just a little bit. It's such a heavy read. If, as you can see, that signature. Yeah. Someone really needs to figure out a nice way to make nice signatures when you're doing functional JavaScript like this. I really don't like it. But since I kind of know how it works, I don't really have to think so much about the signature, and I can read it if I really want to. But here we do the same thing. We compose, and we start with the get user, and we get a user, and that basically means that, as you can probably expect, this entire thing is going to expect a string as an input, which is the user ID. So that we give to the get user, and then that returns a promise of a user, and then we simply extract out the user. We call the delete one function on that user's ID. So the reason why we want to do it this way is because we just want to get the user, because in a RESTful type of thing, we want to return the corresponding user, and delete one is unfortunately not going to return the user that it has deleted. It's going to return a query answer, which is this thing here, which just says how many records were updated and if it actually was successful. But that's not what we want. We want to return the actual user. So that's why we're getting it first. So we delete, and then we simply return the user. And that's our entire function. So through this composition, we're just left with a function that expects a user ID and then deletes the user. And create user is also like, this is how clean it can be, which is so nice. So it takes we can just look at the signature. So it takes a I create user request, which is an interface, or this object here, which is just a name. And then it calls this function first, which in this case, as you can see, it's just going to take the request and convert it into a user. And then it's going to go to the save user, and that's going to take the user and return a promise of a user and actually save it. So the create user request to user, all it does is this thing here. It's just responsible for instantiating the user. And that's pretty much the entire flow. It might be a bit dense to some people. I think that it's a bit dense. Sometimes it can be very, especially, this is a simple case. It can be much more complicated than this. But this is extremely reusable. And thanks to composition and currying, it becomes very easy to build on top of this logic and create very well tested and easy to maintain code. So if we look at, say, testing here, this is the testing that we're going to do. So when we're going to, let's say for the sake of argument, that we want to get all users. Now remember that we instantiate get all users with this magical user function that is called find, that basically knows how to go to the database. But in our tests, we don't really want that. We just want some stub that returns something so that we can test our underlying function. And that's exactly what we do. So we create a mock of the find function, and then we basically just create the get all users function. As we know, like this thing here is a current function, so it expects the function that knows how to find things, and then we just call that function we know with no arguments, and then we can assert. Easy peasy. No need to mock anything, no need to, or rather you don't have to like wire up a database, you don't have to do anything, it's all in memory. It's super quick and super performant when you're running these tests. And then we do the same thing here. We mock the find function, and then this get user function. Notice now that I'm not actually first calling find func and then calling with user ID. I could have done this. These two things are equivalent. They are the exact same thing. I'm first creating a get user function that has the find function that returns another function that expects the user ID. But I can also do this. Because as we were saying, currying means that if I give you all the arguments at the same time, when you have all of them, then just call the function. But if I just give you a few of the functions, you just exhaustively return a new function that expects the remaining arguments. And that's exactly what we're doing. We're filling the requirement by giving all of the parameters immediately. And then we can assert, and the same thing goes down here. Update, no problem there either. We give a stub version of the find function, a user ID, and the updates that we actually want to apply, and then we just assert that the save was called and that the response is what we expect it to be. And delete is the same thing. So testing a functional style of working is extremely easy, and the best part is that the reusability is enormous when it's done correctly. Cons, it's kind of complicated for a lot of people. It can be, at least. All right, let's look at an object-oriented approach. Here we have pretty much the same code. Well, it's the same interface anyway, it's the same APIs. And here things are a little bit different. So here we have a service. So the service, the user service, it knows how to get all the users, how to create users, get a specific user, update a user, and delete a user, and then it knows all of this stuff down here, right? So what's going on here? So let's start by looking at here. Here we have the same models as we saw in the other example. As you can see, it's the same thing, it's just a different collection name, but everything is identical. And here we have some services. Here I do a very similar thing to as we saw in the previous example. So this here is me cheating a little bit. The reason why I'm cheating a little bit here is because this is how I personally believe that you should do object-oriented programming when you're instantiating services. And this idea of services is a concept that you will find in domain-driven design. It's extremely common. I highly recommend you look that up. In Node.js and JavaScript land, it's not so common, but you will for sure know about domain-driven design if you do serious level Java development or serious level C# development. This is pretty much standard throughout the entire industry. And the way that some other languages do this is that they use dependency injection, and they have like, you know, I could technically, this user model that I'm depending on here and passing into my user service, I don't have to pass it in. I could also just reference it here, and you can see I'm actually doing that. That's just to actually have the signature. And then in my case, I'm actually passing in the model like this and just putting it in the constructor like this. But you don't have to, you could just keep it internally. The problem with that is that if you do that, you have the same issue as you have with the functional style. This is the thing where I feel like I'm cheating a little bit, because most people who write object-oriented code would have this thing referenced directly from inside of here. And then the problem becomes that, okay, if you want to do any testing, then you have to start up a database, and you have to actually hit the database with all of these different operations to test the code, instead of keeping it all in memory. Or you could use some magic library like Rewire or something like that to just mock off, or you can use Jest as well, I suppose, to stub off all of these database queries. I feel that is not that great. I think it's much more performant to just use composition here and just actually pass in the database reference and keep it as a field variable on the service. So that's why I'm doing it this way. And another very nice thing with this approach is that here, if you keep all of your instantiation of all the different services in the same file, then when this user service starts growing and it needs to do more complicated things, such as say it needs to do an email thing, well, then I can create like a, I don't know, const email service, which is just this empty object, and then I can actually pass it in using composition again and do email service like that, and I can actually build on top of that. So I have a very nice overview of all of the different services and all the different business logic I have in my system and how they all depend on each other, because services they depend on each other, just as you saw in the functional example where some functions depend on other functions. This is the same idea. Cool, so let's look at this. So this should feel sort of familiar to most people, I suppose, because it's a standard domain service, it's just a domain entity service. And in Java we call it a POJO. In C#, I don't know what they call them in C#, but anywho, it's an object and it can get the user. So we reference this.userModel.find1 and we take in the user ID, standard, and then we search for an ID, get all users, userModel.find, which is our MongoDB reference here, create user, same thing as you saw in the functional thing. It's just going to create a new user, and then it's going to call save and return that user. Update user, same thing here, user ID, takes a request, performs updates, and delete user, performs a delete. Standard stuff. And testing this is very similar, or fairly simple as well. Here we get all the users and we create a stub for the find function, and then we construct this model. This is where I believe that this is much more useful to do than it is to actually internalize the user model or the database access, because now I can in a pure fashion instantiate my user service like this with anything. Like that database model that we have, if that's an internal thing, I have to start a server, because otherwise it's going to blow up in my face. But when I pass it in like this, all I actually have to do is to have a signature that is compliant with the user model. And the user model, like all I'm doing in get all users here is, let's have a look here, get all users. As you can see, really what I need isn't the actual database instance. I just need an object that has the find function and that returns a promise of a user array. That's it. That's all I need. And that's what I'm doing. I'm just creating it here, instantiating, calling my service, and then asserting. Done. Same thing here. And the same thing here is for the update. The thing that you should notice now is that there's a little bit more code in the object-oriented approach here, and that is something that is one of the things that I don't like about this. When you have an object-oriented approach, even if you do this, which is usually a much more sustainable way in my experience to do object-oriented programming than it is to do in other ways with a lot of inheritance and internalizing things and using like annotations and other stuff to inject, it still creates more boilerplate. Because imagine if the user service had an email service. Well, then I have to create an email service, and maybe the email service then depends on some other service, and then I have to create another stub or a mock for that, because I need to create, like, you know, objects depending on objects means that there's an old saying, if I want one monkey, I need to instantiate the whole jungle. It's the same, it's the problem. That's what I really like about functional programming, because it stays very flat. You don't have to instantiate all the dependencies of your own dependencies just to get one function call to go into the code. There's a lot of boilerplate when writing tests for object-oriented code. So this is pretty much the styles. These are only basic examples, and I hope that it's shown you some of the considerations that go into picking functional programming over object-oriented programming. There are so many more nuances to this, so I hope you understand that this is in no way like all the things that you need to consider when you're picking your style. It's just a comparison between the two. and usually the most people feel that object-oriented coding has more boilerplate and the risk of having inheritance problems and so forth. But it's usually simpler for more inexperienced people to digest this rather than it is to digest something like, you know, these sorts of things. Like this is a little bit more foreign to people with currying and composition and stuff like that. But on the other hand, as I said, if you know this stuff, it's extremely powerful. It's really, really cool. So hopefully this was useful to you. Have a great day.